So today we're looking at angle relationships that are formed by intersecting lines. And on this first page, we have 4 different types of angle relationships: vertical angles, adjacent angles, complementary angles, and supplementary angles. First, let's take a look at our vertical angles. So vertical angles are opposite of each other when 2 lines intersect. This problem asks us to find x. So I'm going to look at this pair of vertical angles right here. Notice how they're opposite of each other. Well, vertical angles are always congruent. That's one thing the vertical angle theorem tells us. So we know that their measures are equal. Therefore, 2x plus 2 equals 130. Now it's easy to find x. So in this case, x is equal to 64. How about adjacent angles? Well, adjacent angles share a common ray. For example, these ones I colored in yellow right there. They share a common ray. In this case, they're also a linear pair, since if I put them together, they make a straight line. Here's another example of adjacent angles, highlighted in red, and working my way around here, I can highlight a third pair in blue, and I could even highlight a 4th pair here in green. So there are 4 pairs of adjacent angles in that little pair of intersecting lines that I drew. Let's look at this problem and see what they want us to figure out. Let's see, they ask us to find y, and so that means I want to pick out 2 adjacent angles, one of which involves the variable y. So I'm going to choose these 2 right here. So these 2 angles do share a common ray, this one right there. And what I can tell about them also is that if I put them together, they form a straight line. So they are actually not just adjacent, they're also a linear pair. Well, a line has 180 degrees. So these 2 angles must add up to equal 180 degrees. Let's use that fact to write an equation. We can write 3y minus 10, that's our first angle, plus 130 equals 180, the number of degrees that a line has. Now we just need to solve this equation. In solving the equation, we find that y is equal to 20. So we have 2 more relationships down here, complementary angles and supplementary angles. You probably remember that the measures of complementary angles sum to 90 degrees, and that the measure of supplementary angles sum to 180 degrees. So we can use that fact to solve for the value of our variables in these examples. In this one, we want to find x, and we know that these 2 measures add up to 90. So 28 plus 2x equals 90. Straightforward equation here. So in our first example, we find that x is equal to 31. In the second example, the example for supplementary angles, we'll want to write 3x plus 45 equals 180. And notice again, we could also describe these 2 angles as a linear pair, since together they do make a line. And the solution to this equation is 45. So x equals 45. So these are 4 basic angle relationships that you can use to find the measures of missing angles. Now let's look at parallel lines and transversals. So when a pair of parallel lines is cut by a transversal, special relationships exist between the angles formed. Specifically, alternate interior angles, alternate exterior angles, and corresponding angles are congruent to each other, so their measures are equal. Same-side interior angles are supplementary, so they sum to 180 degrees. That's the relationship that's a little bit different. And remember, this only occurs if the lines are parallel to each other. So let's use these relationships to find the measures of some of the angles shown in our diagrams. So here I have a pair of alternate interior angles. They're alternate because they're on opposite sides of my transversal, and they're interior because they're inside the tunnel. They're in between my parallel lines. And because they're alternate interior angles formed by parallel lines, they're congruent and their measures are equal. So we can write that 5x equals 2x plus 30. Solving that equation, we find that x equals 10. So what are the measures of the angles? Well, 5 times 10 is 50, and 2 times 10 plus 30 is 50. So these are both 50-degree angles. Now here we have some alternate exterior angles. Once again, they're on opposite sides of the transversal, and this time they're outside of the tunnel formed by the parallel lines. That's why they're exterior. And because they're alternate exterior angles formed by parallel lines, they are congruent. So we can write that 24x equals 20x plus 20. Solving that equation tells us that x is equal to 5, and then substituting that into each expression, we find that the measures of our angles are equal to 120 degrees. Now let's look at same side interior angles. They're a little different. These add to 180 degrees. The reason that we say they are same side is because they are on the same side of the transversal. Notice they're both underneath it. And they're interior because they're both in the tunnel. They're between the pair of parallel lines. In this case, they're not congruent. You can tell that one is significantly larger than the other just from the diagram, assuming it's drawn to scale. We do know, however, that they are supplementary, so we can write that the sum of these measures would equal 180 degrees, and that gives us an equation. Solving our equation, we find that x is equal to 40. Our next step is just to substitute 40 into our expressions for our angle measures. And one thing I want to point out here is that our angle measures are not equal this time. Our top angle equals 100 degrees, and our bottom is 80 degrees. So adding them together, we get 180 degrees. We wanted them to be supplementary, and that means that they are. So that indicates that we've done this correctly. Now let's look at our last relationship. That's corresponding angles. And once again, corresponding angles formed by parallel lines will be congruent. So what makes them corresponding? Well, it's that they are in the same relative position when looking at our two pairs of intersecting lines here. In this case, they're both on the bottom of the x, aren't they? That's what makes them corresponding. Well, since they're corresponding angles formed by parallel lines cut by a transversal, they're congruent, so their measures are equal. So we can write 10x equals 8x plus 30. Solving the equation, we find that x is equal to 15. So let's substitute 15 into the values, into the expressions for our angle measures. And in this case, both angle measures are 150 degrees. So that's how you can use angle relationships to find the measures of missing angles.